In this video we will walk you through A to Z of missiles, flying machines, and aerial warfare. We are not giving you a glossary missiles, flying machines, and aerial warfare. We want you to understand the progression from prehistoric to modern and postmodern. This will enable you to take a perspective view of any weapon or aircraft or missile. Earliest weapons to be used included stone, wood, and bone. Hunting from a distance possible with the use of hand axes and wooden spears. Around 6000 BCE onwards swords, the composite bow, became vogue. Also the early chariots came in. A little later came chain mail, and shields protected soldiers. Long sword, poleaxe, and mace were added. Arrows were one of the first weapons used by humans. Sumerian warrior was equipped with spears, maces, swords, clubs and slings. As also weapons like the catapult and trebuchet. A is a type of catapult that uses a hinged arm with a sling attached to the tip to launch a projectile. It was a common powerful siege engine until the advent of gunpowder. Gunpowder was invented in China around the 9th century, brought about the transition from bows and arrows to early firearms, including the fire lance and proto-guns. Cast bronze and iron cannons became decisive on both land and sea. The Industrial Revolution brought interchangeable parts, rifled barrels for better accuracy, and repeating rifles. The mid to late 19th century witnessed the invention of the machine gun, example the Gatling gun, and modern self-contained metallic cartridges. Early 20th century added tanks, military aircraft, submarines, and aircraft carriers, and later nuclear and thermonuclear bombs. A thermonuclear bomb, or hydrogen bomb, is a second-generation nuclear weapon that derives its massive explosive energy from nuclear fusion. Capable of yields hundreds to thousands of times more powerful than early atomic bombs, these weapons use an initial fission explosion to compress and heat isotopes of hydrogen to trigger a fusion reaction. A slice of history: flying machines. Some landmarks. Since prehistoric times people have dreamed of flying. Greeks in about 600 to 1100 BCE. Egyptians around 3000 BCE. Indian Hanuman around 1300 BCE. Around 400 BC, China, the discovery of the kite that could fly in the air by the Chinese. 1485 Leonardo da Vinci, the ornithopter. 1783, Joseph and Jacques Montgolfier, the first hot air balloon. 1799 to 1850s, George Cayley gliders. 1891 Otto Lilienthal gliders. 1891 Samuel P. Langley powered flight. December 17, 1903 Orville and Wilbur Wright and the first airplane. A slice of history: aerial warfare. Aerial warfare is the use of military aircraft and other flying machines such as kites, hot air balloons and aircraft in warfare. Aerial reconnaissance is reconnaissance for a military or strategic purpose. Man-carrying kites in ancient China were used for enemy position reconnaissance and sometimes to lift and drop spies directly into enemy territory to gather intelligence. Airships or heavier-than-air airplanes served in military use in the early years of the 20th century. Most famous of these is Zeppelin, is a type of large, rigid airship, or dirigible, with a metal framework covered in fabric. A slice of history: missiles. In ancient India, missiles were known as astras, supernatural weapons invoked by warriors using mantras. Described extensively in epics like the Mahabharata and Ramayana, these devices such as the formidable Brahmastra were often likened to highly advanced, targeted energy or elemental weapons. Ancient Indian missile systems possessed unique characteristics and are deeply tied to the culture's history. The concept of the astra: an astra was a projectile or thrown weapon. Warriors imbued everyday weapons, usually arrows, with spiritual or natural energy by chanting specific mantras. Targeting and control. Certain texts suggest that the mantra functioned similarly to modern mission control software, guiding the projectile to its target. The Brahmastra, the most revered astra was the Brahmastra, described as an uncontrollable cosmic missile that could cause widespread destruction, sometimes drawing comparisons to modern atomic weapons. Historical evolution of rockets. Centuries later, in the 18th century CE, India transitioned to physical rocketry. Tipu Sultan of Mysore successfully utilized iron-cased rockets in the Anglo-Mysore Wars, proving the region's long history of deploying projectile technology. Today, the heritage of Astras continues to heavily influence the nation's defense sector. India's modern strategic arsenal features numerous missiles named after deities and mythological concepts, such as the Agni, fire god, and Astra, divine missile. 10th century China, the earliest documented usage of rockets involved bamboo tubes filled with gunpowder, primarily used as fireworks or battlefield propulsion systems. 19th century Europe, British Colonel William Congreve adapted the Mysorean rockets into the Congreve rocket, which were widely used during the Napoleonic Wars. V-1 and V-2, Nazi Germany developed the V-1, an early cruise missile/flying bomb, and the V-2, the first operational ballistic missile. The V-2, powered by liquid propellants, marked the dawn of modern long-range rocket technology. Glide bombs, early anti-ship and air-to-ground guided glide bombs, like the German Henschel HS-293, were developed, controlled by simple radio command guidance. Next, fighter aircraft and air-to-air combat or dogfight. Key features: straight, unswept wings, manual controls, basic guns/rockets, and no radars. Famous aircraft: Germany's Messerschmitt Me 262, the first operational jet fighter, the UK's Gloster Meteor, and the US Lockheed F-80. Key features: swept wings for transonic speeds, afterburners, the introduction of early radar, and the first air-to-air guided missiles. Famous aircraft: North American F-86 Sabre, Soviet MiG-15, and the supersonic MiG-21. Key features: Mach 2 plus speeds, variable geometry, swing, wings, and the maturation of long-range, beyond visual range, BVR, missiles. Famous aircraft: US McDonnell Douglas F-4 Phantom II, Soviet MiG-23, and the French Dassault Mirage 3. Key features: fly-by-wire computer flight controls, highly agile airframes, look-down/shoot-down radars, and heavily integrated digital cockpits. Famous aircraft: US F-15 Eagle, F-16 Fighting Falcon, F/A-18 Hornet, Soviet Su-27, and European partners Eurofighter Typhoon. Key features: internal weapons bays, low observable, stealth, shaping and coatings, advanced data link networking, and thrust vectoring engines. Famous aircraft: US Lockheed Martin F-22 Raptor, F-35 Lightning II, Chinese Chengdu J-20, and Russian Sukhoi Su-57. Key features: next-generation adaptive cycle engines, optionally manned or autonomous, AI, loyal wingman teaming, directed energy, laser, weapons, and unprecedented electronic warfare capabilities. Ballistic missiles armed with nuclear warheads, and were stockpiled by the United States and the Soviet Union to deter each other from using them. A ballistic missile is a rocket-propelled guided weapon that is powered during its initial launch phase, then follows a high, arc-like, free-falling trajectory largely governed by gravity and momentum to deliver a payload onto a predetermined target. Trajectory follows a parabolic, suborbital, or orbital flight path. Boost phase: the rocket engines ignite and propel the missile out of the atmosphere. Mid-course phase: engines shut off, allowing the missile to coast through space or the upper atmosphere. Terminal phase: the warhead re-enters the atmosphere and descends rapidly toward the target. Payloads: they can be fitted with conventional high explosives or nuclear, chemical, and biological munitions. Launch platforms: these missiles can be deployed from land-based silos, mobile launchers, aircraft, and submarines, SLBMs. Ballistic missiles are typically categorized by the maximum distance they can travel. Short range, SRBM less than 1,000 kilometers, also known as tactical or battlefield missiles. Prithvi 2, India is short range, liquid-fueled tactical ballistic missile with a range of 250 to 350 kilometers. MGM-140 ATACMS, United States, a tactical SRBM fired from ground platforms like the HIMARS, utilized widely in contemporary conflict. Medium range, MRBM 1000 to 3000 kilometers. Agni-3, India, a highly accurate, solid-fueled MRBM with a range between 3000 kilometers and 3500 kilometers. Jericho-3, Israel, a primary Israeli ballistic missile, often classified between medium and intermediate range. Intermediate range, IRBM 3000 to 5500 kilometers. Range, 3000 to 5500 kilometers, 1860 to 3400 miles. Agni-V, India, a land-based, nuclear-capable IRBM with a range exceeding 5000 kilometers. Intercontinental, ICBM greater than 5500 kilometers. LGM-30G Minuteman III, United States, the only land-based ICBM in the U.S. operational arsenal, capable of carrying multiple nuclear warheads. Dongfeng 41/DF-41, China, a highly capable road-mobile ICBM designed to strike global targets with a range of up to 15,000 kilometers. Rs-28 Sarma, Russia, a heavy, liquid-fueled ICBM designed to carry a massive payload of nuclear warheads. Submarine-launched ballistic missiles, SLBMs, these are ballistic missiles specifically designed to be carried and launched from submarines, offering mobile stealth capabilities. Riden 2D5, United States/United Kingdom, a highly reliable SLBM carried by U.S. Ohio-class and UK Vanguard-class submarines. K-15 Sagrika, India, a submarine-launched ballistic missile developed by India with a range of up to 700 kilometers. SAM or surface-to-air missile examples are cruise missiles traveling primarily within the atmosphere and relying on jet engines for sustained propulsion. They fly at lower altitudes, often skimming the terrain, to avoid radar, acting essentially as precision-guided, uncrewed flying bombs. They are classified by speed. Subsonic, speeds below the speed of sound, example nearby. Supersonic, speeds between Mach 1 and Mach 5, example BrahMos. Hypersonic, speeds exceeding Mach 5. Surface-to-air missiles, SAMs, designed to intercept incoming aircraft, helicopters, or other missiles from the ground, example Akash. Anti-tank guided missiles, ATGM, surface-launched missiles directed to destroy heavily armored vehicles and tanks, example NAG. Anti-ballistic missiles, ABM, specialized surface-to-air systems built specifically to intercept and destroy attacking ballistic missiles in mid-flight. Drone warfare using relatively cheap unmanned equipment proliferated in the 21st century. Drone warfare is a form of warfare that involves the deployment of military robots and unmanned systems. The unmanned systems may be remote-controlled by a pilot or have varying levels of autonomy during their mission. Drones are a force multiplier that may supplement, or reduce the necessity for, live personnel during operations. Types of unmanned systems and platforms include unmanned combat aerial vehicles, UCAV, or weaponized commercial unmanned aerial vehicles, UAV, unmanned surface vehicles, USV, or unmanned underwater vehicles, UUV, and unmanned ground vehicles, UGV. 1S UAVs and MAVs are man-portable UAVs and can be deployed for low-altitude, short-range support operations. Autonomous drones such as autonomous aircraft and LAWs utilize artificial intelligence or pre-programmed algorithms. Collection of imagery intelligence, observation of enemy maneuvers and artillery spotting. Air combat maneuvering, ACM, is the tactical execution of moving, turning, and positioning a fighter aircraft to gain an offensive or defensive advantage. Commonly known as dogfighting, ACM builds on foundational flying skills by emphasizing coordinated wingman tactics, rapid energy management, and situational awareness. Gathering information about incoming aircraft or tanks or soldiers. Gathering information on incoming military assets like aircraft, tanks, and soldiers relies on advanced reconnaissance and intelligence gathering, often referred to as intelligence, surveillance, and reconnaissance, ISR. This is achieved through a combination of radar systems, satellite imagery, signals interception, and open-source intelligence, OSINT. Radar and ADS-B tracking, standard aircraft emit transponder signals, ADS-B. While sensitive tactical and fighter jets are usually hidden or unencrypted, transport, cargo, and refueling aircraft can often be tracked using tools like FlightAware or Flight Radar 24. Satellite imagery and remote sensing, high-resolution commercial satellites can capture troop movements, vehicle staging, like tanks, and airfield activity. Signals intelligence, SIGINT/ELINT military forces scan the electromagnetic spectrum to intercept adversary communications or radar signal. Gathering intelligence on incoming military assets at night relies on active and passive detection systems designed to bypass the visual limitations of the dark. Technologies such as radar, infrared sensors, and radio signal interceptors reveal movements that darkness attempts to hide. 1. Airborne surveillance and early warning. Airborne warning and control systems, AWACS. These highly modified aircraft use powerful radar systems to sweep wide geographic areas, detecting low-flying aircraft, ships, and vehicles well beyond the Earth's curvature. Reconnaissance aircraft, specialized platforms like the AC-130 gunship use advanced low-light and infrared sensors to see in the dark, acting as real-time command posts. Thermal imaging, FLIR. Forward-looking infrared systems detect heat signatures rather than visible light. Because engines, machinery, and human bodies emit heat, thermal optics easily silhouette soldiers, tanks, and aircraft against the colder ambient night temperatures. Night vision devices, NVDs. These devices utilize image intensifiers or infrared spotlights to amplify ambient starlight or moonshine, rendering the invisible visible to ground patrols. Ground surveillance radars, GSR. Portable or vehicle-mounted radars send out radio frequency beams that bounce off moving targets, like troops marching or tanks moving, identifying their distance, direction, and speed. ADS-B and transponder tracking, for civilian and some unencrypted military aircraft, systems capture and decode broadcasted transponder data using software-defined radios and antennas, mapping positions onto platforms like Flight Radar 24 or FlightAware. Radio direction finding, intercepting battlefield communications or unencrypted radio transmissions allows intelligence analysts to pinpoint the geographical origin of troop movements, utilizing tracking principles similar to those outlined in Plane Spotting, an updated guide to tracking aircraft around the world. Synthetic aperture radar, SAR, satellites. SAR payloads illuminate the Earth's surface with microwaves and measure the backscatter to create high-resolution, photographic-like maps of the ground. Because SAR generates its own illumination, it captures high-detail imagery through thick clouds and total darkness. Gathering information about incoming aircraft or tanks or soldiers at night. A missile is a weapon which is propelled by a rocket motor towards the target. Projectile is an object that is propelled by the application of an external force and then moves freely under the influence of gravity and air resistance. A projectile has no propulsion. It is hurled towards the target. A stone thrown from a catapult is also a projectile.